Imagine your phone buzzing on a random Friday afternoon. It's a text message from your boss, and it instantly vetoes this project you've spent the last 6 months designing.
Which is, yeah, the ultimate nightmare scenario for anyone.
Right. But now, imagine your boss isn't actually human. It's an AI. And it didn't kill your project because the idea was bad or anything. It killed it because your deployment plan required a human being to manually click a single approve button instead of like having an automated script handle it.
It really does sound like science fiction, I mean, when you put it like that. But it is entirely real. What we're looking at today represents this fundamental shift in how work is actually governed.
Oh, absolutely. Welcome to the deep dive, everyone. For you listening, whether you're, managing a corporate team, coding software, or just trying to keep your own daily to-do list from swallowing you whole, our mission today is to explore a truly fascinating stack of architectural system audits and operational protocols we've acquired.
Yeah, because we are moving away from the idea of IT as this static blueprint, where a human comes in with a metaphorical wrench to fix things. And we're moving toward a system that operates much more like a biological entity.
Exactly. We're going to uncover how a system ruthlessly transitions from what the documents call T1.1 hobbyist toil to a strict, impenetrable T1.2 Fortune 500 ready state. And the wildest part, it does this entirely through an aggressive corporate immune system governed by an AI known simply as the chief auditor.
Right. These documents, they basically outline a relentless war against manual human effort. The system doesn't view manual intervention like the patching, the break-fix maintenance, all that copying and pasting we all do every day. It doesn't view that as a necessary evil.
No, it really doesn't.
It views it as an existential threat, like a literal virus. And it calls this virus infrastructure debt.
Okay, let's unpack this. Because if we're treating a corporate IT architecture like a living organism with an aggressive immune system, I really want to understand the blood work. Like, how does this system actually diagnose what is healthy and what needs to be, attacked? And you mentioned the primary metric here is infrastructure debt.
Yes, exactly. So the system calculates a strict ratio to determine its health. It basically takes the sum of your unaligned assets.
Which is what exactly?
Well, it's essentially anything messy, unstandardized, or manual in your architecture. So it takes those unaligned assets and it divides that by your total assets. And the system mandates that the resulting number must be exactly zero. Always.
Wait, exactly zero?
Exactly zero. Any fraction above zero triggers what the chief auditor logs as an architecture fault. And the entire system just halts until that debt is completely eradicated.
Wow, and an unaligned asset isn't just broken code, right? Because I was looking at the recursive scan protocols in the source material, and it's looking for what it calls legacy strings, which are literally just words.
Yeah, just everyday words.
Like, if it finds terms like home lab or sovereign gauntlet or technical earth buried anywhere in an operational script or even just an internal wiki, it flags it as an infection.
Precisely. Because to the chief auditor, language dictates reality. If a script contains the word home lab, the system deduces that the mental framework of the architect is, well, it's still stuck in a casual hobbyist tinkering phase.
Right, like they're just playing around in their basement or something.
Exactly. It isn't deterministic. It isn't enterprise grade.
But I have to push back on that a little bit because it sounds incredibly rigid. Are we really saying that just leaving the word home lab in a random forgotten line of code crashes a Fortune 500 deployment? Because think about what that means. It's like moving into this pristine multi-million-dollar smart home, but the ultra-advanced security system locks you out on the range simply because you brought one ratty old college t-shirt inside.
That smart home analogy is actually perfect, really. But what's fascinating here, you have to look at it from the perspective of an auditor evaluating the security of that home. In a T1.2 architecture, semantic residue is technical debt.
Semantic residue, I love that term.
Right. If you don't eradicate that hobbyist mindset at the literal syntax level, you just cannot mathematically map your system to strict global compliance standards. The documents actually explicitly cite ISO IEC 27001 and NIST SP 853.
And those are massive, highly rigorous international security framework.
They are. A Fortune 500 company just cannot prove compliance to a third-party auditor if their internal documentation and their code bases are just littered with casual, unstandardized jargon. Ambiguity is the absolute enemy of compliance.
Because it leaves room for human error.
Exactly. The system requires absolute semantic purity to guarantee that every single component is measurable, secure, and legally sound.
Okay, so if a single word can cause a system halt, how does it handle actual human fatigue? I mean, humans make mistakes when they're tired, right? That brings us to another really fascinating piece of blood work in these documents, which is the force index. This is basically measuring a worker's metabolic capacity.
It is, yeah. And the calculation behind the force index is just brilliant. It evaluates the raw energy or effort a specific project requires, and it divides that by the human architect's available capacity, plus any systemic friction that might slow them down.
So it's essentially a ratio of how much juice you have versus how much the job demands.
Exactly. It's mathematically quantifying human energy to prevent burnout. The documents actually project this massive 40% market ROI entirely by recapturing engineering hours.
Wait, 40%? That's huge.
It is. They use a debt neutralizer to automate away the tedious maintenance tasks. So taking all those hours, a human would have spent putting out fires and, well, weaponizing that time for actual market value.
So it's like built-in mathematical self-preservation. But if you think about it, understanding the math is kind of the easy part, right? The real challenge is enforcement. Because humans are just messy, we take shortcuts, we always promise we'll go back and automate that script later, and we literally never do. So how does a mathematical ideal actually enforce its will on unpredictable humans?
Well, it uses a supreme authority, the chief auditor. And the chief auditor acts as the ultimate sovereign shield of the enterprise.
Yeah.
It doesn't just, review plans. It actively antagonizes them.
Yeah, that's its core directive. It operates on what the documents call mismatch logic. So it is fundamentally prompted to play devil's advocate against you. When you submit a plan, it does not look for reasons to approve it. It systematically hunts for any logical inconsistency, any manual dependency, or any security gap just to kill it.
Right. And when it finds one, it issues the sovereign veto. According to the documents, the chief auditor will literally send a formal veto via text message if a plan includes any manual break-fix tasks, or if something called the sovereign index drops below 60%.
And what exactly is the sovereign index?
It's essentially a strict measure of jurisdictional authority and security isolation. They maintain that 60% threshold through a strategy they call the sovereign vault and the citadel.
The citadel. Sounds very dramatic.
It does, but it's crucial. Because in enterprise software, supply chain contagion is a massive risk, meaning a vulnerability in one small external tool can infect your core production environment. So the Citadel strategy mathematically isolates your live environment. If you propose an idea that opens the Citadel doors even a millimeter to an unverified external tool, the veto comes down instantly.
So let me get this straight. If I'm a developer and my deployment plan gets vetoed by this algorithm via a text message, I can't just change a font or tweak a sentence and try submitting the exact same plan again, right?
Oh, not at all. No. The chief auditor forces you into what the protocol calls the WIE loop. That's the wisdom externalization loop.
Okay, so if I'm stuck in this WIE loop, it sounds like the system is essentially forcing me to automate myself out of a job before it lets me proceed. I have to take whatever knowledge was in my head that caused me to rely on a manual step in the first place and build it into the system.
That is exactly what it's doing, yeah. If your operational plan required you to manually parse data, the WIE loop demands you stop everything and build a permanent system asset instead. You might have to write an automated script or feed your process into a retrieval augmented generation database, a RAG.
And for those listening who might not be super deep in AI architecture, a RAG is basically a specialized custom brain that the AI can read, so it can perform your specific tasks based on your own internal company data.
Exactly right. It allows the AI to reference your specific knowledge base.
Right.
So by forcing you into this WIE loop, you literally convert your manual skill into an automated API call. The system systematically extracts the human operational burden and shifts it entirely onto deterministic AI agents.
Which means the actual execution of the work is no longer done by human hands at all. Because if the chief auditor blocks everything manual, the work has to be done by highly specialized automated agents operating under a strict hierarchy. And the environment they operate in is organized into what's called a quad-tier directory. It's not just a list of folders, it's a very specific flow of data.
Think of the quad tier as the 4 core pillars of a digital enterprise. First is GOV, which handles all the strategic governance and compliance.
Right, making sure everything is legal and standardized.
Exactly. Then there's data, which is an immutable ledger of all system intelligence. From there, information flows into Brain, which uses Vertex AI, that's Google's enterprise machine learning platform, to create a semantic knowledge graph. It essentially learns how the company operates from the ground up.
Wow, and then what's the last one?
Only after passing through all of that does anything touch PROD, the tactical execution layer or the live environment.
So that's the actual terrain. But how does a piece of code or a business objective actually move through these four pillars? Like, how do the AI agents know what to prioritize?
That is governed by the priority decision tree. The system ranks absolutely everything. Priority 1 is mandatory action. This is entirely dedicated to eliminating technical toil.
Okay, so give me an example of priority one.
Well, for instance, if humans are manually copying meeting notes into a documentation folder, the system will mandate an app script intravenous routing to automate that exact data flow. It is the absolute highest priority because it directly targets and destroys infrastructure debt.
Got it. And then you have priority two, which is refinement, which from the source material looks like it's about synchronizing agent logic, making sure the different AI personas are communicating perfectly with each other.
Right. And then priority 3 is purposed. These are static doctrines or frameworks used for what the documents aggressively call market weaponization.
Market weaponization. They really don't hold back on the terminology, but here's where it gets really interesting to me. Who executes these priorities? Because it's a very specific cast of AI agents. You have the intelligence director, whose job is to aggressively strip out conversational fluff to enforce strict syntax. Like, if a human writes, hey, I think we should maybe route this to the backup server, the intelligence director converts that into a raw, mathematically readable command.
Right. Completely removes the human hesitation.
Yeah.
And you also have the chief engineering officer, which evaluates the code and issues the actual build authorized clearance.
But of all the AI agents in this stack, I think the most intimidating, or maybe the most brilliant, has to be the quartermaster. The quartermaster is the agent that actually calculates that force index we talked about earlier. I picture the quartermaster like a bouncer at an exclusive nightclub. But instead of checking your ID or seeing if you're on the guest list, it evaluates your raw effort against your capacity. If the ratio says you're going to crash halfway through a sprint, the velvet rope stays closed. You're not getting in.
It's such a great analogy, and it completely reframes how we look at productivity. I mean, think about your own workday. How many times have you pushed through a project deploying something late on a Friday night when you were just running on empty?
Too many times to count, honestly.
Right. And in a traditional company, human resources monitors burnout usually after the fact, like when someone quits or takes medical leaves.
Yeah, it's entirely reactive.
But here, the quartermaster agent mathematically evaluates the cognitive load of a sprint before allowing the architect to physically deploy code to the GCP marketplace, which is Google Cloud Platform's digital storefront for software. If the math indicates that the human in the system cost is too high, the system locks you out. You cannot deploy. It is built-in deterministic self-care.
That is just wild. Okay, so we've explored the theory. We understand the mathematics of infrastructure debt. We've seen the agents mapping out tasks. Let's actually look at what happens when this theoretical system meets reality. Because the source documents contain the chief auditor's exact verdicts on two major real-world proposals. One survives the gauntlet, and the other is ruthlessly dismantled.
Let's start with the proposal that survived. It was called the EAP Empirical Validation Research Clearance. The chief auditor actually granted this a provisional clear. And the reason it succeeded is that it didn't just promise efficiency. It provided the mathematical proof.
Right, it proved it could eradicate manual toil. It utilized rigorous telemetry, explicitly measuring mean time to internalize, or MTTI. It measured exactly how long it took for human knowledge to become an automated system asset.
Furthermore, it incorporated DORA metrics. And for anyone unfamiliar, DORA metrics are essentially the gold standard in software engineering for measuring how quickly and safely a team writes and delivers code. It measures things like deployment frequency and mean time to recovery. So by building automated dashboards around these metrics, the proposal proved it was deterministic.
And crucially, it explicitly mapped its internal logging directly to the ISO A.12.4.1 compliance standard, which governs logging and monitoring procedures. It spoke the chief auditor's language flawlessly. It proved it was secure, automated, and compliant.
Now, you have to contrast that surgical precision with the failure. The second case study is a proposal called the Tactical Strike Web3 and DAO Pivot. This is a pitch to transition the infrastructure to a decentralized architecture. And the chief auditor's verdict was a hard, immediate veto.
The reasons for the veto are honestly brutal to read. The proposal suggested utilizing external Web3 hosting environments, specifically mentioning IPFS and a Fleek. And worse, it required human users to manually set up digital wallets.
Yeah. The mismatch logic of the chief auditor caught those vulnerabilities instantly. Relying on external air-gapped identities completely shattered the sovereign index. It dropped it far below that critical 60% threshold. And because the enterprise couldn't instantly automate the tracking and securing of those external wallet assets, the calculated infrastructure debt just skyrocketed.
And the auditor's wrath didn't even stop at the technical architecture. It went after the language again. The auditor demanded the immediate eradication of any terminology referring to Phase 1 escape. It forced the architect to reframe the entire project narrative as a Tier 1.2 infrastructure transition. It essentially said, "We are a Fortune 500 entity, stop talking like a rebel hacker."
Which is pretty funny when you think about it.
It is. But I have to ask, because Web3 and decentralization are widely considered the bleeding edge of modern technology, why did this hyper-advanced AI-governed system swat Web3 away like a fly?
This raises an important question, really. Because to a strictly governed enterprise system, decentralization without perfect native automation isn't innovation. It's just chaos. The entire T1.2 architecture relies on a single source of truth, an immutable ledger where every single action is logged, monitored, and automated within the company's controlled environment.
So if you bring in an external network, you just lose that control completely.
Exactly. Relying on external networks outside the workspace's native automation completely breaks that single source of truth. The system values absolute coherence, security, and deterministic control far above integrating the latest trendy technology. If the system cannot measure it, isolate it, and automate it, it treats it as an unaligned asset, a literal threat.
Wow. Which brings us back to exactly where we started. Whether you are running a massive corporate infrastructure or just trying to manage your own team's daily workflows, there's immense power in this paradigm. Treating manual, repetitive, break-fix toil not as a normal chore you just have to get through, but as an unacceptable debt that must be eradicated.
It does reframe everything, and it leaves us with a rather profound implication to consider as we wrap up today. We've seen that AI agents, like the chief auditor and the quartermaster, can perfectly regulate complex corporate infrastructure. They can mandate global compliance standards, strictly enforce security, and even mathematically prevent human burnout using deterministic logic.
All without a human manager ever stepping in.
Exactly.
Right.
So the question becomes, how long until human middle managers are entirely replaced? If an algorithm can seamlessly execute mismatched logic on architectural code, how long until it governs our daily emails, our project proposals, and our resource requests? Imagine an AI that instantly vetoes your budget request because it calculates that your plan relies on manual data entry rather than an automated API. We're looking at a future where enterprise alignment isn't managed by human consensus, but enforced by algorithmic physics.
The corporate ecosystem where inefficiency isn't just frowned upon, it's mathematically impossible. That is a staggering thought to end on. Thank you for joining us on this deep dive into the architecture of autonomic governance. As you go back to your day, we encourage you to critically evaluate your own workflows. Ask yourself, what is your personal infrastructure debt today, and what manual toil do you need to eradicate to finally get it down to zero? Catch you next time.